Hope you all are doing well. So I, Umesh Patil, welcome you all for the fifth lecture on course of thermodynamics. So far, only 7 students have joined the lecture. So let's wait for a minute so that the student will join. Hurry up, students. Dear student, please ensure to join the lecture 5 minutes before the scheduled time. The lecture is to be started at 10:30. So it is expected that you should join a lecture at 10:25. So far, 9 students joined the lecture. May I audible? Students, may I audible?
Yes, sir.
And the sound is clear?
Yes.
Okay, okay. Thank you. Thank you, Shubham. Let's wait for a moment, for a minute, then we'll proceed. Okay. So students, in previous lecture, we discussed about various gas laws, that is Boyle's law, Charles law, and Gay-Lussac law. These laws gives a relation between pressure, volume, and temperature, which are the fundamental properties of any system. Any thermal system or any fluid is having pressure, volume, and temperature. And these are the characteristics of properties are nothing but a characteristics of any substance. So we studied in detail in previous lecture these gas laws. Then we covered microscopic and macroscopic viewpoint of studying the thermodynamics. In microscopic view, the analysis is done at molecular level, and it involves lot of mathematical equations or lot of mathematical models are needed to do the thermal analysis by using a microscopic viewpoint of thermodynamics, which is also called as the statistical thermodynamics. So this approach is rarely used, or it is used only in case of studying the gases which are at low temperature or studying the substances which are at very high temperature. And the second approach of studying thermodynamics is the macroscopic viewpoint, which is also called as the classical thermodynamics. So here the properties of the systems are measured, and these properties are used to get a energy transfer across the system boundary. So onwards we are going to use the classical thermodynamics viewpoint of studying the thermodynamics, which is also macroscopic viewpoint. Then we started system. System is nothing but a matter under study or space which we consider under study, thermodynamic study, that is called as the system. Okay, and system is exchanging energy. Anything outside the system is surrounding. So system is exchanging energy as well as mass with the surrounding, and the real or imaginary surface which separates system from surrounding is boundary. So boundary may be fixed one or it may be movable. So we'll see later on in same unit how the boundary is fixed or it is movable, and in some case it may be real or it may be imaginary. Okay, so this system, boundary and surrounding is very important concept in thermodynamics. Whenever you want to do thermal analysis of any system, it should be clearly you should clearly able to differentiate, or you should clearly able to define system, boundary and surrounding. Okay, and in this current lecture we'll go through various types of system, properties of the system, equilibrium and its type. Okay, so before moving towards the systems type, uh, let's have one quiz. So I am putting the quiz link in the chat box. So dear students, please attempt the quiz. So this quiz is just to check whether you understand whatever we learned in the previous session. So this quiz is based on the topic we covered in previous session, lecture 4. So again this quiz is open for 5 minutes. So start attempting the quiz. Students, please attempt the quiz. This quiz is just to evaluate whether you understand the topic that we covered in previous lecture. If the average score of the quiz is less than 7, then I am going to repeat the topic that we covered in previous session. Otherwise, we will proceed with the next topic. So far, only 2 students have attempted the quiz. Remaining student, hurry up, attempt the quiz. There are just 2 questions in a quiz, each carrying 5 points. So far the average score is 6.1, 6.4. If this average score is less than 7, I consider that most of the student doesn't understand the gas laws. This quiz is based on the gas laws that we learned in a previous session. So far 30 students replied, attempted the quiz. Okay, let's see the responses. Remaining student attempt the quiz. So far 15 students attempted the quiz, 17 students. Pradeep, very good, 10 out of 10. Keshav Golab, 10. Rohit, 10. Abuzar, 10. 10 out of 10. Tejas, 10 out of 10. Asif, 10 out of 10. And the average score so far is just 5. So from this, I may conclude that only 50% student understood the gas laws. Okay, I am stopping the quiz here. Okay. Okay, students. So the average score of all the student is nearer to 5. So only 50% student understood the gas laws that we learned in previous session. Okay. So doesn't worry. I'm going to repeat that topic. So basically gas laws. My screen is visible. Please reply. Somebody please reply. PPT is visible.
Sir.
Yes, sir. Yes, sir.
Okay, okay. Thank you. Okay, so we quickly revise the various gas laws. So when we uh, when we try to correlate pressure, volume and temperature by using the various gas laws, the first gas law is Boyle's law. Okay, so generally as a student you get confused between these various gas laws. Okay, so whenever there is Boyle's law or whenever you want to correlate pressure with the volume, so pressure always varies inversely with the volume. You can take n numbers of example in day-to-day life. Okay, so whenever we increase the pressure, the volume will decrease. Let's take an example of a rubber ball. If you squeeze the ball, means you are increasing the pressure on the surface of the ball. Okay, and as we increase the pressure, the volume of the ball decreases. So it is according to the Boyle's law. So Boyle's law says at constant temperature pressure is inversely proportional to volume. Okay, clear? Please reply. Boyle's law, whether it is clear? Pressure always varies inversely with a volume at constant temperature. Real life example, cold drink bottle. Then second law, Charles law. Okay, so Boyle's law gives relation between pressure and volume. Charles law gives relation between volume and temperature. Okay, so Boyle's law B, Charles law C. Okay, and if you write pressure, volume and temperature in a sequence, so first Boyle's law B means it will give relation between pressure and volume. Second law is Charles law, which give relation between the next two terms, that is volume and temperature, and the previous one is constant. So at constant pressure, volume is directly proportional to the temperature, that is Charles law. I hope by using this trick you will understand the Charles law. Okay, so Charles law will give relation between the second and third fundamental properties. So first fundamental property is pressure, second one is volume, third one is temperature. Okay, so when pressure is kept constant, when first property is kept constant, the remaining second and third property, they are directly related with each other. So volume is directly proportional to temperature, or temperature is directly proportional to the volume, vice versa. So both cases are possible. So temperature is directly proportional to volume, or volume is directly proportional to temperature. That you clearly observe from this graph. So pressure and temperature, sorry, volume and temperature are varying directly with each other. So this is Charles law. Now the remaining relation is between pressure and temperature, first term and third term. Okay, so in next gas law, that is Gay-Lussac law, when volume is kept constant, pressure is directly proportional to temperature. And the real life example of Gay-Lussac law is the car tires or a motorcycle tire. Okay, so if you measure the pressure of the cold tire and if you measure the pressure of the hot tire, again as the temperature of tire increases, the pressure of air inside the tire will also increases. So it is according to the Gay-Lussac law of thermodynamics. Okay, so I hope you understand the basic gas laws, pressure, volume and temperature, which gives relation between pressure, volume and temperature. Clear, students? Okay, now let's proceed to the I hope this microscopic and microscopic viewpoint is clear to you. Again, we started system, boundary and surrounding. Okay, so here in this lecture we'll go through system types, properties equilibrium and its various types. Okay. So we defined system in last lecture. A quantity of matter, a certain quantity of matter or region in space chosen for study is nothing but a system. So you can see here in this diagram. So this is the system, okay, and the region outside the system is the surrounding. So generally our most of the thermal devices, they are exchanging energy as well as mass with the atmosphere. So okay, so our thermal device is the system and atmosphere is the surrounding, okay, and there will be a real or imaginary boundary which will separate this system from surrounding. That is nothing but a boundary. That boundary may be fixed or it may be movable, okay. And again there are various types of systems. Systems are generally of two types, control mass and control volume, or it is also called as closed system or open system. Okay, so let's start with the closed system. Closed system is also called as the control mass system. So if you see this diagram, a cylinder containing a gas and it is fitted with a piston. Okay, so this gas inside a cylinder is a system. So gas will not cross the boundaries of the cylinder. So no mass will cross the boundary of the cylinder. So cylinder is a system and this outside is the surrounding. Okay, and this cylinder walls are nothing but a boundary. Okay, so here these boundaries are fixed one. Okay, so there is no mass transfer in a closed system. Only exchange between surrounding and system is energy. So energy will cross the system boundary in case of closed system. And the example of closed system is pressure cooker is an example of closed system. So mass does not cross the or mass will not move outside the pressure cooker, but its energy may enter into the pressure cooker or it may be rejected from pressure cooker to the surrounding. So burner will give heat to the food inside the pressure cooker. So energy is transferred. Again heat will be rejected from pressure cooker to the surrounding. So energy transfer is happening in a pressure cooker, but no mass is crossing the system boundary. So it is an example of closed system. And second example you can take from day-to-day life, refrigerator. Okay, so in refrigerator, the refrigerant is continuously moving, same amount of refrigerant is continuously moving in a refrigerator. It will not come out of the refrigerator. Okay, so again it is the example of closed system, but energy will cross the system. System is our refrigerator. Okay, so it is rejected from refrigerator to the surrounding. So heat transfer is taking place, but there is no mass transfer. So such type of systems are called as the closed system or a control mass system. Now let's come to the open system, or which are also called as the control volume, and most of the thermal devices are open system or control volume. If you take an example of a water heater, okay, so it is a open system. If we take example of nozzle, again it is a open system. If we take example of a compressor which is used in garages, in workshop, in various factories, even domestic refrigerator is having a compressor. So in compressor, the fluid is continuously entering, it is compressed and again it is delivered. Okay, so mass is continuously entering and it is leaving the system, as well as energy exchange takes place between system and surrounding. So such type of systems are called as the open system. And the examples, most of the thermal devices are open system or a control volume. Example, you can take compressor, turbine, nozzle. In this slide, a picture of water heater is shown. So cold water is continuously entering it is heated and it is delivered. Hot water is continuously delivered. Okay. So water heater is again example of open system. Okay. Again take an example of piston cylinder arrangement. So this piston is reciprocating inside a cylinder. Okay. So here mass is entering. Okay. And it is continuously leaving. And again if you see these two diagrams, one diagram, this one nozzle, and second one is this piston cylinder arrangement. So here in nozzle is having a two type of boundary. The walls of nozzles are the real boundary, and the inlet and outlet of nozzle is the imaginary boundary. And if you come to the piston cylinder arrangement, it is having fixed boundaries, that is wall of the cylinder, and again it is having a movable boundary, moving boundary, because piston is reciprocating inside a cylinder. So this boundary is continuously moving. It may be here if there is a compression, or it may be here when there is a expansion. So this boundary is movable boundary, moving boundary. Okay. So I hope open system is clear to you. Okay.
Yes,
Now,
sir.
now understood. In closed system, we can easily do the thermal analysis as mass is not crossing the system boundary. So it is having a definite volume, definite mass. So thermal analysis of closed system is quite a bit easy, or we can easily do the thermal analysis of the closed system. But if you want to do a thermal analysis by using a classical thermodynamics approach, then this becomes difficult, because mass is continuously entering and it is leaving. There is no fixed mass for doing the analysis. So for doing the analysis of open system, it is considered that the open system is surrounded by a imaginary surface which is called as the control surface, and whatever energy transfer and mass transfer is happening, that is taking place within this control surface. So that control surface, space bounded by that control surface, is called as the control volume. So mass transfer will takes place across this control volume, as well as energy transfer will happen across this control surface. So by using the concept of control volume, we can do the thermal analysis of open system. Because as an engineer, we often need to select a nozzle, turbine, boiler, throttle valve. These all are the thermal devices which are very commonly used in, which is having very large application in industrial field, as well as in power industry, as well as in pharmaceutical industries, automobile industries, aviation industry. Everywhere these devices are common: compressor, turbine, nozzle. Okay, so we must able to do the analysis of these thermal devices. It may be compressor, turbine, or nozzle. Okay, so it is done with the help of control volume, and control volume is nothing but a volume within the control surface, and control surface is the imaginary surface within which the mass transfer is taking place. So if you observe this diagram, so here mass is entering from inlet and it is leaving. Okay, so this is the open system. And again there is third type of system, that is isolated system. Okay, so we define types of system on the basis of mass transfer and energy transfer. If there is no mass transfer and only energy transfer is happening, that type of system is a closed system. If mass as well as energy transfer is taking place, that type of system is open system. And third type of system is the isolated system. So in isolated system, there is neither transfer of mass or not transfer of energy. Okay, so whenever there is no energy transfer, no mass transfer, that type of system is called as the isolated system. Can you give the example of isolated system? Anybody please try to reply. Whether can you give example of isolated system?
Thermos.
Thermos. Very good. Correct. Partly thermos is the isolated system. I hope everybody know about the thermos. So thermos is generally used to store the hot water or a tea or coffee. Okay. And if we keep hot water in a thermos, suppose 1 liter thermos. So if we pour or if we fill that thermos with 1 liter of water having temperature of 50 degrees Celsius, and we kept that water for a certain time interval in a thermos. Suppose we keep that water as it is in a thermos for half an hour. And again if you check after half hour, the temperature of water will be almost 50 degrees Celsius. So what it indicates, and again if you measure the mass of the water, if you poured 1 kg of water, after half an hour the mass of water will be 1 kg. Means mass is not crossing the thermos. Thermos is our system, so it is not crossing the boundaries of the thermos. And again as the temperature is constant, temperature of water will be 50 degrees Celsius after half an hour. So it indicates there is no energy transfer. So thermos is the example of the isolated system. But in real life, it is very difficult to find the isolated system. Okay. Again, if you keep the thermos for a longer duration in an atmosphere, you will find that there is drop in temperature of the water. It indicates there is a energy transfer through the walls of the thermos. The walls of thermos are nothing but a boundary, and atmosphere is the surrounding, and a liquid or water inside a thermos is our system. You can observe this phenomenon. Keep a water at certain temperature inside a thermos. After 10 minutes, measure the temperature. It may be same, but if you keep that water inside the thermos, hot water inside the thermos for longer duration, 1 hour, 2 hours, and if you observe after 2 hours, there will be a drop in temperature. So what it indicates? It indicates that there is a energy transfer. Okay. So in practical, it is very difficult to develop or to manufacture the isolated system, but till we consider thermos as the isolated system. Okay. So clear system and types of system. Again I am repeating, system is a quantity of matter or space in a region under study, under thermal study, that is called as the system. System is outside, anything outside the system is surrounding, and system is separated from surrounding by a boundary. That boundary may be real or it may be imaginary. Okay, and again there are various types of system according to the mass transfer and energy transfer. If there is mass transfer across the system as well as energy transfer is taking place, that is called as the open system or a control volume system. If there is no mass transfer but energy transfer is taking place, that type of system is called as the closed system, or it is also called as the controlled mass system. In that system, mass is controlled. And the third type of system in which there is no mass transfer or there is no energy transfer, that type of system is called as the isolated system. Okay. So system and types of system is clear. Now let's come to the important topic in fundamentals, properties of a system. Okay. So properties are nothing but a characteristics of the system. If you want to define a fluid, so that fluid is defined by using certain characteristics. Okay. So these characteristics are pressure, temperature, volume, mass. Let's take example day to day life. If you want to fill a petrol in a motorcycle, okay, so that petrol is having a density. If you go on petrol pump, the density is displayed over that digital board, digital display. You will get a density of the petrol. So again, density is nothing but a characteristic of the petrol. Again, you fill that fuel tank with certain amount of petrol, 1 liter, 2 liter, half liter. Okay, so that 1 liter, 2 liter is nothing but a unit of volume. Okay, so again you are characterizing that petrol by using volume and density. Okay, so any characteristic of a system is called as the property of the system, and the fundamental properties are pressure, temperature, volume and mass. Okay, and these property are divided into two types. First one is intensive property and second one is extensive property. So there is a student generally gets confused between intensive property and extensive property. Whenever there is a word intensive, intensive means independent of mass. The properties which are not dependent on mass of the system, that type of properties are called as the intensive property. Okay, and the extensive property means properties which dependent on the mass of the system, that type of properties are called as the extensive property. Okay, so you just understand intensive property, opposite to that is the extensive property. Intensive means independent of mass, and opposite to that extensive property which are dependent on mass of the system. Okay, so if you see temperature, pressure and density, these are the intensive property. Why these are the intensive properties? Again, this topic is very, very important. Why temperature, pressure and densities are intensive properties? Please reply.
Because temperature depends on surrounding, not mass of the system.
Very good, absolutely correct. Because
Pressure is externally applied and density is constant for that particular system. Therefore,
very good, absolutely correct, absolutely correct. Very good. So temperature, pressure and density, if you observe these properties of a system, if you take, let's take an example of temperature. Okay, so you are carrying a water bottle with you. Okay, so if you take, if suppose you are having a water bottle of 1 liter, so again 1 liter water means 1 kg water. If you take out some of the water from a bottle and if you measure the temperature of that water, it is generally a room temperature. So let's say it is a 30 degrees Celsius. And if you again measure the temperature of water which is left in a bottle, again it will be same. Do you agree with this? आपके पास पानी का बॉटल है, उसमें 1 लीटर वाटर है, उसमें से कुछ वाटर आपने बाहर निकाल लिया और जो वाटर बाहर निकाला उसका टेम्परेचर अगर आपने मेजर किया, ठीक है, तो कुछ वैल्यू होंगी टेम्परेचर की. लेट्स से इट इज 30 डिग्री सेल्सियस. एंड अगेन इफ यू मेजर द टेम्परेचर ऑफ वाटर विच इज लेफ्ट इन अ बॉटल, ठीक है, तो वाटर जो लेफ्ट हुआ है बॉटल में उसका मास अलग होगा और जो वाटर आपने बाहर निकाला बॉटल में से उसका मास अलग होगा. ओके, और अगर दोनों का टेम्परेचर आपने मेजर किया द टेम्परेचर विल बी सेम. सो व्हाट इट इंडिकेट्स? The temperature does not depend upon the mass of the system. ठीक है, जैसे पानी की टंकी है 1000 लीटर की, 500 लीटर की ओवरहेड टैंक. इफ यू टेक आउट अ बकेट ऑफ वाटर एंड इफ यू मेजर द टेम्परेचर ऑफ दैट वाटर and again the temperature of water in a tank, it will be same. So from this we can conclude temperature does not depend upon the mass of the system. Similarly pressure, absolutely correct, it is the external force applied over the certain area. So again it does not depend upon the mass. And density, again we know water. What is the density of water?
1 into 10 to the power 3 kilogram per meter cube.
Absolutely correct. The density of water is approximately 1000 kg per meter cube. Means if we take 1 meter cube of water, its weight will be, sorry, its mass will be 1000 kg. Okay, it is generally 998 kg per meter cube, but for the ease of calculations, for simplifying the calculation, it is taken as 1000 kg per meter cube. It indicates 1 liter of water means its mass will be 1 kg. Okay, so density is nothing but a mass per unit volume. Mass divided by volume is the density. Okay, again it is independent of mass of the सिस्टम. ठीक है, अगर आपने वाटर लिया 1 लीटर वाटर लिया तो उसका डेंसिटी 1000 ही होगा, और 10 लीटर वाटर लिया 10 kg वाटर लिया तो उसका डेंसिटी भी 1000 ही होगा. ओके, एग्री विद दिस? करके देखो एक्सपेरिमेंट. 1 किलो वाटर ले लो, 1 लीटर वाटर ले लो, उसका डेंसिटी मेजर करो, और जो बचा हुआ वाटर है बकेट में उसका डेंसिटी काउंट करो. द डेंसिटी विल बी सेम. सो इट इंडिकेट डेंसिटी डज नॉट डिपेंड अपॉन द mass of the system. That's why it is a intensive property. Clear? And opposite to that is the extensive property. So extensive property is dependent upon the mass of the system, and the example of extensive properties are mass and volume. Okay, mass and volume are the extensive properties. Temperature, pressure and density are intensive properties. So don't get confused between intensive and extensive. Understand intensive or remember intensive, and opposite to that is the extensive property. Okay, so in intensive property is independent of mass. So pressure, temperature and density are the intensive property. Okay, so let's come here. A container is containing certain fluid having mass m, volume v, temperature T, pressure P and density as rho, Roman letter rho. Okay, and if we divide this system or container into 2 equal parts as shown by this dotted line, so what will happen to the mass? If we divide this container into 2 equal parts, mass will be divided. 50% mass will be on first part and remaining 50% will be in second part. Okay, so half mass in first part and half mass in second part. Similarly, volume, if the volume of container is 1 liter, so 1 liter water in first part and half liter water in first part and half liter water in second part. Okay, temperature, it will remain constant. फर्स्ट पार्ट में जितना टेम्परेचर होगा सेकेंड पार्ट में भी उतना ही टेम्परेचर होगा. प्रेशर, इट विल बी सेम, फर्स्ट पार्ट सेकेंड पार्ट. अगेन डेंसिटी विल बी सेम. सो फ्रॉम दिस यू कैन डिफरेंशिएट द प्रॉपर्टी विच विल डिवाइड is the extensive property, and the property which will remain constant is the intensive property. That is the meaning of this, or that is the interpretation of this diagram. So I hope intensive and extensive properties are clear to you. Okay, so again in next lecture we'll have a quiz again on gas laws, and I am expecting that all of you will get an average score of 9 out of 10 in a same quiz. Just I am going to change the questions. Again it will be based on gas law. And then lastly, specific properties. So extensive properties, per unit mass is the specific properties. So if we divide volume with mass, so it will be specific volume. Volume divided by mass is specific volume. Okay. So I hope this much contents are sufficient for today's lecture. If you have any doubts, please ask.